Hi everyone, hope you are doing good. So, today we have to do section 9.5, which is hypothesis test for one population mean when sigma is unknown. This is really important. Still, from section 9.1 to 9.4, we discussed this hypothesis test when sigma is known. So this case sigma is unknown. So remember that when sigma unknown, you cannot use your C C value or C value approach. You cannot use C. I'll mention C here, something like this. Okay. So you cannot use C. So C test is not valid anymore. So let's see how we deal with this kind of test when sigma is unknown. Okay, still we can perform our test. As I mentioned in section 9.4, we discuss hypothesis testing when population standard deviation is known. But in real world, yes, population standard deviation is usually unknown. Okay, in real world scenarios, we don't know what is the standard deviation value. So when we need to perform the hypothesis test, we cannot use simple C test. So we need something instead of one simple C test. In this section, we are discussing population standard deviation is unknown. What we are going to do. Okay, remember that. Population standard deviation is unknown. We have developed a method same as C test we call one sample T test. Okay, this C test and this C test and this T test they are very close to each other, but they are different. Okay, let's see what is this T test. You remember that what we have done in the T test case. Okay, we had two tail case, left tail or right tail. Same as C test, in T test we have two tail test, left tail test and right tail test. Same cases, it doesn't change. Okay, when your alternative hypothesis is not equal, mu not equal mu naught, then you have to deal with two tail. Okay, uh, h naught always same, mu equals mu naught. Okay, so if you have mu less than your mu naught, you have to deal with left tail. If your mu greater than mu naught, then you have to deal with right tail test. Same as C test, it doesn't change. Okay. uh at what time do we need to use this T tail test? Oh, we need to use this T test. Okay, T test, we call one mean T test because we have to consider just mu. Okay, when population standard deviation is unknown and sample size is less than 30. You know, when sample size is greater than 30 and you know what is the population standard deviation sigma, then you can do C test, right? But you don't know what is the standard deviation and sample size less than 30. So you have to use another method. That method is T test. Okay, so how we calculate this T statistic? We call this T statistic. Why? This is the value we are going to calculate, same as C statistic. Okay, we call this T statistic, which means our test statistic. Okay, under H naught, X bar, which is your mean, mu naught, you can pick that value from your H naught. So S is the sample standard deviation. Okay, uh, N is the sample size. Mu naught is taken from H naught. Okay, It's very same to C statistic formula, but different is this. Let me pick another color. Okay, difference is this values S, sample standard deviation. For the C test, or let's say in the test statistic C, we had what, sigma, but here in T test we have S. Okay, that's the major difference in this formula. Okay, let's compare these two, C test and T test. Both are one mean test, so I'm not going to consider that. uh, they are pretty similar, but they have few difference. Main difference is the table what we are using to find critical values and p values. For the C test, we use C table to find the critical value and p values. In the T test, we are going to use T table. Used to we use the T table to find critical value and p value. Okay. Also, in this test statistic of the one mean T test, we use sample standard deviation instead of population standard deviation. Sample standard deviation means S, population standard deviation means sigma. Sigma unknown, we don't know this guy. That's why we use simple S, which means sample standard deviation. Okay. Okay. At what time we need to reject S node? Same as C test, same format, so you don't need to worry about that. Only thing is this test statistic, that notation is different. Okay. Whenever when we consider critical value approach, in two-tailed case, test statistic greater than T alpha over 2 or test statistic less than negative T alpha over 2, which means something like this, we reject our H naught. Okay. Left tail test, test statistic value less than this TL, negative T alpha over 2, which means something like this, we reject our null hypothesis if our value inside this rejection region. Right tail test, we use when test statistic value greater than T alpha over 2, something like this. Same picture what we used in previous chapters, previous sections. Okay. So this is critical value approach. Then let's consider the p-value approach. In p-value approach, you know how to in the C test, one means C test, you know how we found the p-value based on two tail test, left tail test, right tail test. Same method here. If this is two tail test, then how we find the p-value? 2 times area. Okay, we reject if p-value is less than your significant level. So p-value less than your alpha, we reject H naught. Okay. Then left tail test under p-value approach, we calculated p-value in C test, same as what we are talking about here. Area to the right of the test statistic. Okay. Negative, that value, get the negative sign. Okay, this value. So reject H naught if p value less than your alpha. P value less than alpha. Okay. And also here I forgot to mention that in p value cases are very same. So whatever inside the rejection region, we reject it. Okay, that's the one and only rule. Then right tail test, how we calculate p-value. Oh, sorry, these spelling mistakes. LUE. Oh my god. Okay. Area to the right of the test. Reject test note if p-value less than our alpha. Okay. Okay. Same technique what we used in chapter 9.4. Okay, let's see how we use this T table. T table is little bit different from the C table. It is in your formula sheet, table 4, first column. Okay, first column, take a look at this one. First column in the C table, it's mentioned DF, simple D, simple F. That DF mean degree of freedom. DF mean degree of freedom. Degree of freedom, how we calculate this degree of freedom? Always, remember that, always n minus 1. Okay, always n minus 1. N mean number of observations you have. Always n minus 1. Okay, then uh, first column, the head title of the first column, something like this: T 0.01. Next one, T 0.05. These are the significant level. Okay, these are the significant level alpha value. T means just notation. T, this value. Okay, so you have to consider only the value, not the T. Just forget about the T. Anyway, in each column they have mentioned that particular alpha value. So if you, for an example, if you consider this column, throughout this column from top to bottom, T alpha value is 0.005. Okay, alpha value is 0.005. It has a different degree of freedom. When you go from top to bottom, degree of freedom, it is changing, it is increasing. Okay, okay. If before you use the T table, you should know two things. First, what is the degree of freedom, this guy, and the other one is what is the alpha. Okay, using those two you can figure it out what is the value. Okay, okay, let's see an example. When degree of freedom is 4, okay, your alpha is 0.05. How we get the value? Let me select another color. Okay, so first go down the first column, degree of freedom, locate the degree of freedom equals 4, this one. Next find the alpha value. So 0.05, 0.05 in this column. Okay, in this column, go down this column and go along this vertical line, go along this horizontal line, come down vertically and go through horizontally. You will find, when the intersection point, you will find the particular value. When they meet each other, that's the value. Here it is 2.132. Okay, this degree of freedom and alpha value we denote by using this notation T. Okay, this is a T value. First your alpha value, comma, next degree of freedom. In general, this is how we denote a T value or T statistic value. Clear? This is a general notation. You don't need to stick with this one, but if you use this, that's okay. First your alpha value, significant value, then degree of freedom, like I mentioned here. See, let me erase this. Okay, like what they have mentioned here. It is general notation. If you are familiar with that, you can use that, no problem. Okay, always body section in this T table, it gives you a probability values. Okay, it gives you a probability values. Do you remember, is this a question, this is a question, if you remember in C table, in the body part, okay, what it tells you, what did that body values tells you? It's area, right, under curve, under that bell shaped curve, right? uh so that values between, in between 0 to 1. Do you remember that? Why? Those probability values from 0 to 1. But here I told you it's probability, it's not probability. I mentioned something else. Here the body part, these values are not probability values. Probability values are these, see, alpha, those are probability values, but this value is not probability values. They may have huge number of huge values, see, 3, 6, 12, 31, 63, something like that. Those are t values. Okay, t values. So you will see how we deal with these t values. Okay, okay. If you consider two-tailed test, same as previous cases, uh, when your alternative hypothesis mu not equal mu naught, one part goes alpha over 2, the other part goes to alpha over 2. So t value, when you figure it out, 1 t alpha over 2, which means 1 t alpha over 2 value, then same value, change the sign. Okay, find out degree of freedom and alpha, then find the value for alpha over 2. Find the value here, it should be t value. Okay, refer the t table with degree of freedom n minus 1 and alpha over 2, find the t value which I talk about in second step. Okay, let me go through this again. First find the alpha value and degree of freedom, so you know what is alpha and degree of freedom. Then find the alpha over 2, which means alpha divided by 2, what's the value. Now you can find what is t alpha over 2, because you know what is the degree of freedom, you know what is alpha over 2. Go to the t table and find what is the t alpha over 2. Negative t alpha over 2 mean this value which you got in third step, change the sign, negative sign, plug the negative sign, that's it. Okay, same as C test. Left tail test, when mu less than mu naught, you have to use the left tail test. First find the degree of freedom and alpha, then refer the t table to find t alpha. Degree of freedom, you know what is that, alpha, you know what is that. So find the t alpha by using your t table. uh, that t value, you need to get the negative of that particular value, because you need negative t alpha, because this time you need to find left tail, you need to work with left tail. So left tail, it is negative t alpha. Okay, so right tail test, when mu greater than mu naught, you can find t alpha. First find the degree of freedom and alpha, then find the t alpha using t table. Okay, just that value. Okay, there are few things you should familiar with before you work with this t table. I know it is a little bit tough, but actually it is very easy, same as C table. Okay, only thing is you should figure it out how we do this step by step. Okay, let's find some critical values based on t table. Okay, here I have mentioned 5 problems, just how to find these C values based on each case. I'll do two of them. Okay, I'll try to do first one and third. The first one and third one. Okay, but please try all these five. Okay, okay. First one, n equal 15. Significant level 0. Significant level 5%. So n 15. Okay, n 15. Uh, no, n is not 15, n should be 25. I'm so sorry, n should be 25. Okay, n is 25. N is 25. Alpha, this is significant level, which means your alpha 0.05. Okay, I'm sorry, there are a few typos here in this slide. Please check them. Okay, first one, left tail test. Have I mentioned it? Okay, left tail test. Yeah, first one is left tail. Okay, since this is left tail, so okay, you know what is n, so you can figure it out what is degree of freedom, n minus 1, so it is 24. You know what is alpha. This is left tail, it doesn't matter. First try to find this value, t alpha comma, sorry, uh t alpha comma degree of freedom. So alpha 0.05, degree of freedom is 24 here. So go to the t table, find the degree of freedom 24. Next find what is alpha, which is 0.05, this one. Go down, go this side, then you can figure it out, this intersection point 1.711. Since you are, see, now you have figured out what is T alpha. Since you are using left tail test, you have to take negative T alpha. So you have to flip the sign. So critical value is negative 1.711. Okay, you have to flip the sign since you are dealing with left tail. So you should remember that which test or which tail you are using. Okay, that's the important thing here. Okay, let's try to do another one. Okay, here n equal 10, alpha 10%. Alpha 10% means 0.1. Okay, n is 10. So first uh, this is right tail test. So first you have to find degree of freedom and alpha. You know what is n, so you can find degree of freedom, it is 9, alpha 0.1. Okay, refer the t table to find t alpha. Since this is right tail test, you have to figure it out what is t alpha. So t alpha 0.1 when degree of freedom is 9. So go to the degree of freedom column, find 9, then go to the column 0.1. 0.1 is this one. So this column, sorry, this row, this column. So what is the intersection point? This guy. Okay, 1.383. Since this is right tail test, just the value 1.38. Okay, okay, please try to do the other three examples. Okay, make sure you know how to find t values. Now we are going to follow the steps what we need to do to find this hypothesis testing when sigma is unknown. Okay, first step, state your null hypothesis and alternative hypothesis. Always remember H naught is mu equals mu naught, always. An alternative hypothesis is it based on your claim. It based on your claim. Based on your claim, you have to pick whether it is two tail, left tail, or right tail. Step number 2, find out significant level alpha and degree of freedom. Degree of freedom, simply called DF. Okay. Step number 3, calculate the test statistic T. That value, let's say T naught. So how we calculate this T? X bar, which mean your data set mean or sample mean, minus mu naught directly from your H naught, divide by S. S mean sample standard deviation. If they have given a table, you can simply calculate X bar and S using those formula in your formula sheet. Okay, and divide by square root of n. You can calculate T naught. Okay, pick one method: critical value approach or p-value approach. Then interpret the results. So we have 5 steps. Let's see. Large software company gives job applicant test programmable. The mean for that test has been 160 in the past. 25 job applicants are randomly selected from a large university, and they produce a mean score 183 and a standard deviation of 12. This mean and standard deviation based on what? 25 job applicants are randomly selected from a large university. So this part is your sample. So they have given sample mean, mu, and sample standard deviation. Clear? Based on 25. So your n is 25. Clear? Okay, test using alpha. Okay, 5% significant level, which means you alpha. Test whether the mean score for student from this university is different from 160. Different. What does different mean? Not equal. Okay. So, what kind of tail is this? Two tail. Why? Different. So, first use critical value approach. Step number 1, state the null hypothesis and alternative hypothesis. You know what is the alternative hypothesis? Not equal 160. Uh, Null hypothesis or alternative hypothesis, always mu equals the given value. Okay, this is two-tail test. I have mentioned it here again, two-tail test. Step number 2, find the significant level alpha. It is 5%, which means alpha 0.05. Compute the test statistic T. You know what is X bar, what is N, what is S, right? Standard deviation, sample mean, and number of observations. They have given, plug those values into this equation, then you can get your T naught value. We are using critical value approach. Okay, so T naught value is 9.58. Okay, uh, then what? Since this is two tail, you have to find what is alpha over 2. Alpha is 0.05, alpha 2 is 0.025. You know what is degree of freedom? It is 24. So you have to find T alpha over 2, okay, using your T table, and also you will need degree of freedom. So go to the T table, first find the degree of freedom 24, and then locate the column alpha over 2. Alpha is 0.05, so alpha over 2 is 0.025. Come down along this 0.025 column and go horizontally through this degree of freedom 24. When they meet each other, that's the value, that's the T alpha over 2 value. So here T alpha over 2 value is I think it is, sorry, 2 point, I'm sorry, this is okay, uh, 2.064. Okay, since you know what is T alpha over 2, you can figure it out easily what is negative T alpha over 2. Change the sign. Okay, so these are the values. Clear? Okay, then you can compare your test statistic test statistic value T naught is 9.58. So where is 9.58? This value this is positive, so this value is 2.064. So where is this guy? This guy somewhere here, right? So that guy is inside the rejection region. Okay, so easily reject H naught. That's it. Decision it decision it does not depend on C table or T table or C test or T test. Okay, it just based on the technique. Okay, at the end, step number 5, what's going on here? Sorry, test statistic value T naught greater than your critical value. Okay, which mean in rejection area we reject H naught. So 5% alpha, 5% significant level, 5% level of significant, we reject our null hypothesis, which mean our alternative hypothesis. We have enough evidence to say that mean marks for the test is different from 160. Okay, this part again is your claim. Okay, okay, let's see how to use p-value. P-value approach is a little bit complicated. Okay, okay, same as before, state the null hypothesis and alternative hypothesis. Done. Okay, since this is two tail, okay, significant level 0.05, compute the test statistic, no matter what, same result. Okay, 9.58. We are under p-value approach. Okay, now what we have to do? We have to find the p-value based on this T naught. Since this is two tail, okay, degree of freedom, same degree of freedom, uh, we need to find the probability value for relevant T naught. So probability values are here. All the T naught or T values inside the body. Okay, it's not like C table. Please try to understand the steps clearly. Okay, we need to find relevant, we need to find the p value based on T naught, our calculated value. Okay, you should know degree of freedom. It is 24. Degree of freedom is this. Okay, I'll use another color again. Let's say which color? Green color. Okay, first you should locate your degree of freedom. When you locate your degree of freedom, it is fixed. Okay, it is fixed. You cannot change this row. Okay, now you have to locate the closest value of your test statistic value. Test statistic value is 9.58. So what is the closest value? This one, this one, this one, this one, this one. 9.8. There is no value after this. See, this is again degree of freedom. So you can just forget about this one. The first column and last column, they are same. Okay, so after this point there is no value. So what is the maximum value you can get from this column, this row? 2.797. You can see that it is not very close to 9.58, but there is nothing to do with that. You have to pick that value because you cannot change the rows. You cannot go down because this degree of freedom is fixed. Okay, then you have to select this value and go up, pick your p value. Based on this value you can pick your p value. it is 0.005. Then take relevant probability. See, closest value, this one, we can take the area 0.05. Okay, 0.05. When you consider this probability values from left to right, from this side to this, values are decreasing, right? 0.1, 0.05, 0.2025. Okay, so when it is the area or the probability value belongs to 9.58, definitely less than 0.005. Okay, somewhere in right side, somewhere here. So we have p-value 0.005, but how we calculate the p-value? This is two-tail test. This is two-tail test. 2 times 0.005. So your p-value is less than 0.01. Why less than? Because your real area is not 0.005. It is less than that value. Okay, it is less than that value. So your p-value is less than 0.01. Compare that p-value with alpha 0.05. Definitely alpha is greater than your p-value. So reject test note. Okay, same conclusion at the end. Okay, so in this case you will see that it's not like C test. When you are going to find the p-value, it is really complicated. Why? Because we don't have enough values to deal with uh, p-values. Let's pick another color. Let's say this one. Okay, see, when you are coming from left to right, 0.01, 0.005. When you go somewhere here, let's say here, it is definitely what happened, less than 0.05. You don't need this column, actually it is same as first one. So there is no value here. Yes, true, but what happened? The column, the row value is fixed. You have no choice, so you have to get the closest one. But this is not the exact value, so value definitely less than this value. That's why here p value less than 0.01. You can calculate the value by multiplying 2, but it is less than that value. Okay, in general, for the t-test, we do not recommend, check this box, we do not recommend p-value approach. Why? You can see here, see this one, it is like it's like you can easily get stuck. Okay, so I recommend that you it is better if you use critical value approach in t-test. It's just a idea. Okay, you can use both, it doesn't matter, if you can use whatever you want, but critical value method is the best option in t-test. Okay, okay, uh, there is another example. In this example, they have given their alpha value. Time failures between failures is greater than, okay, this is the keyword, greater than this value, which means this is mu greater than 520. Right tail test. Okay, they have given a data set. How many observations? 10. So your n equals to 10 here. You have to calculate your x bar and s using this formula. If you remember that this formula you can find in your formula sheet. Okay, you have to calculate these two values, then you are ready to go. State the null hypothesis and alternative hypothesis. Okay, they have mentioned here. Why this one alternative? Because they have mentioned greater than. Okay, okay. Then significant value alpha 0.05. Compute the test statistic. You know what is x bar, you know what is s, you know what is n. Plug those values into this formula and get the t naught value. Okay, t naught is 2.61. I'm going to use the critical value here. That's the easiest one. Okay, so what you have to do? You have to find t alpha. Okay, positive t alpha, because this is right tail test. So alpha 0.05. You know what is the degree of freedom? It is 9 and minus 1. So go to the t table and find t 0.05 comma degree of freedom. That value is 1.833. Okay, so you have your t alpha value and you have your t naught value. That t alpha value is 1.833, t naught value is 2.61. So test statistic value greater than your critical value t alpha. So what you have to do? So your t this is t alpha, your t naught somewhere here. Just say here, your t naught. Okay, this point. So your t naught value is greater than t alpha value, which means you have to what? It is in the rejection area. You have to reject H naught. It is easy. Reject H naught. Okay. Test statistic value T naught greater than T alpha. T naught in rejection area. So you have to reject the null hypothesis. Reject the null hypothesis. So you can say that we have enough evidence to say that your what? Claim. Mean time between failures greater than this value 520. Okay. Clear? So this is how we deal with t-test. I know this is something like complicated in the first place, but believe me, when you are going through the problems, when you solve few problems, it is same as c-test. Only different is here I recommend you to use critical value approach rather than p-value approach. Okay, so I hope you understand the concept. Okay, that's the end of this section. If you have any question, please let me know. Please go through the materials once again and make sure you have done all the necessary uh, steps. You have completed all the necessary steps to find hypothesis test or to conduct this hypothesis test using t-test. Okay. Okay. See you guys in next lesson. Have a great day. Thank you.